Welcome. Today I'm going to show you how to use the weighted overlay tool in ArcGIS software. This is a very powerful tool. You can use it to combine different raster layers into something. Today we'll be combining four hazard layers into a landslide hazard map using weighted overlay tool. We have 5 layers today, one vector file, that is the study area boundary known as Kutupalong Rohingya Camp, in short KRC. We have the land cover type of the study area. There are 6 land cover types here, vegetation, and you have different colors. You have the surface elevation between -5 to 37.337 meter. You have NDVI, that is the vegetation index. The higher the NDVI, vegetation coverage is higher or healthier there. And slope from 0 to almost 87 degree. Before we start, you have to quickly check the layer properties. For land cover, if you go to properties, go to source, and for this kind of weighted overlay analysis, remember all the layers should have the similar properties. For example, the same number of columns and row here, 855 columns and 10,705 rows. The cell size should be the same. Here it is 0.5 by 0.5 meter cell. For all the layers, the pixel type should be integer, and you have the extent should be the same, and the spatial reference should be the same. Let's go to the next layer, elevation, properties. I have checked it, all are the same. All have the same properties except the pixel type. The other one, I told you it should be discrete integer, but here you have continuous floating points. So you have to convert it to discrete integer. I will show you next. The same happens for NDVI and slope. So I'm happy with the land cover layer. It has, if you go to the attribute table, you can see it has 6 types of land cover. So the value 10 represents vegetation, 40 represents cropland, 8 represents water body. And you can change the color from here. Let's say I want to change the color to green, leaf green. Select and change. Save it somewhere. So the land cover layer is integer type, so we can use it for weighted overlay analysis, but the elevation needs to be reclassified. We call it reclassification into some classes. It depends how many classes you want, but if you go to the symbology, let's change the color from green to red. So lower elevation will be showing green color and higher elevation areas will be showing red color, and in between is yellow. And apply, OK. I just changed the color. I can also have classes. So from stressed you go to classified. How many classes you want, it depends on your study area and local context. But I will have for my study area 5 classes. And I'm going to again have green to red. Click OK. So now I have 5 classes for my elevation layer. But I'm still not happy. I want to do some more editing just for better visualization. I don't want so many decimal numbers. Left click, format labels, and change it to 0. It means I just have no decimal numbers. It's better represented now. Also, you can also do manual editing. For example, if you click the classify here, and manually I can change. Now it is showing the range values between -5 to -9, 10 to 14, 15 to 19, but I want it -5 to 10, then 15, 20, 25, and the highest is 37 point something, but you can make it a bit higher, 40. And it has changed to manual classification. I'm happy with the classification. Click OK, and you see it has changed from -5 to 10, 11 to 15, and all these. Apply, OK. So what I did, I have changed the symbology from continuous to classified. I have 5 classes for the elevation. So the dark green areas should be between -5 to -5 to +10 meter, and the red colors are representing 26 to 40 meter elevation. Now go to Spatial Analysis Tools from the Arc toolbox here and go to Reclassify. Now I want to permanently reclassify this raster layer into reclassed elevation. Because here I have just changed the symbology, but I haven't changed the properties. To do that, we reclassify. The input raster should be elevation. Now you can see these old values will convert into 1, 2, 3, 4, 5. So remember, 5 means for your reclassified elevation layer is 26 to 40, and all these values. If you're happy, click OK. No need to rename here. We will be renaming later. OK, and wait. We will see it is now working, showing reclassify. So always remember, for weighted overlay analysis, you need raster layers with similar properties, and they should all be reclassified. Our land cover layer is already reclassified, so we don't need to do it, but the rest 3, elevation, NDVI, and slope, we need to reclassify. Okay, so here is the reclassified elevation layer. Let's change the name to reclass elevation and change the color again from the color scheme green to red. Yes, it's done. So we have now a reclassified elevation raster layer with 5 classes, and remember, 1 represents -5 to 10, 4 represents 21 to 25. So keep it here. Yes, I'm happy with it. Now let's go quickly and check the properties. Source, and from floating point it has converted into discrete integer, and all the properties are the same: row number, column number, cell size, pixel type, extent, all same, and spatial reference, that's the map, projection, and coordinate system, all are the same. So we have 2 layers now ready. Let's save it, ready for weighted overlay analysis, land cover, and reclassified elevation layer. Now let's quickly do the same for NDVI. I'm not going to explain here too much, but I'll be quickly doing it. NDVI symbology. NDVI should be red to green. Color scheme should be selected, because the higher the NDVI value, the greener the area should be, and the lower the NDVI value, it should not be strong vegetation. It can be built up area or water bodies or bare soil. Okay, so from the NDVI you can quickly tell me these areas, the red areas, are highly built up areas. I want 5 classes. I will do it quickly. Classified 5. Manual, I want it from 0.1, 0.2, 0.25, 0.3, and 0.5. So these are my class. You should do the classification based on the local context, always remember, and the requirement for your study area. I know this classification works best for my study area, and I have done it. And color should be red to green. Apply, OK. I don't want so many decimal places. Change it to, I want 2 decimal places because this is NDVI. The values range between -1 to +1. Okay, I'm fine with it. Let's reclassify NDVI, and all these old values will be converted into new values 1, 2, 3, 4, 5. But I know what is what. 5 means NDVI values between 0 to 3 to 0.5. OK. And you will get the reclassified NDVI raster layer. It is still working. Let's wait. And next, I will again very quickly, I'll be doing slope reclassification. When all the 4 reclassified images are ready, we'll be running the weighted overlay tool. So this is the reclassified NDVI, rename it to, and color should be red to green. You can use any suitable color. And for NDVI, I know 1 means minus 0.0421. Now lastly, I will work on slope. Classified, I want 5 classes, 10 degree, 20 degree, 30 degree, 40 degree, and 90 degree. I have 5 classes. OK. I don't want so many decimals here. 0. OK. And slope should be, the higher the slope value, the more dangerous that area. Like the steep slope is dangerous for landslides, so it should be green to red, or whatever color scheme you can select any one you want. I'm happy with it. So on the original layer, I have reclassified the slope into 5 classes between 0 to 10 degree, 11 to 20, 41 to 90 degree. So the red areas are highly risky for landslides. Now let's do the reclassification. Now slope, 1, 2, 3, 4, 5 classes. I'm happy with it. Click and wait for the slope reclassified slope layer. It takes a little bit time because the raster layer size is really, heavy file, and the pixel size is really very high resolution pixel, that is 0.5 meter by 0.5 meter each pixel. It has been added. We'll rename it to reclass slope. I know what does it mean by what. For example, 1 means 0 to 10 degree, 5 means 41 to 9 degree. Now I have 4 raster layers with all the same properties for them. The same source, all the columns and rows, cell size, pixel type are all integer now. Extent is the same and spatial reference is the same. If they are not the same, you cannot run the weighted overlay tool. I'm telling you, even if there is a single cell number is which mess, it will not run. Now go to Spatial Analyst, Overlay, Weighted Overlay tool. Here you need to add, you can add as many layers as you want. If you want to do hazard mapping, then you should have hazard layers for a study area. You should have at least, ideal to have 3 layers and more. Don't have too many layers, then it will complicate your analysis. And for vulnerability mapping, you need vulnerability layers, and exposure mapping, you need exposure layers. And if you can combine all of them, at the end you can get risk map. But today, let's say these are the 4 hazard layers for my particular study area. The 4 layers are land cover, slope, reclassified NDVI, and reclassified elevation. I will add them here. The plus sign, add raster row is land cover. This is my first. I have added them. Second layer is reclassified slope. Third layer is reclassified NDVI. And fourth layer is reclassified elevation. So with this tool, first you need to, so I will be doing landslide hazard mapping for my particular study area. You have to define, based on experience, judgment, and literature review, which layer is most important for a study area. And this is called percentage of influence. Total should be for all these layers 100. And the higher the influence you give, the higher priority you give to that raster layer. Let's do this is, it shouldn't be done randomly. You should have a proper knowledge on a study area. You can conduct expert opinion survey, and there are many other ways to assign the influence. But for today, based on my 10 years of experience working in this area, I want to give highest priority to land cover. I want to make them all 100. The sum should be 100 because it is not 100 now, 35. That's why this red cross is here. Elevation for my study area is important. I give 15%, NDVI 25%, slope 30%. Let's see what's the sum. I can reduce it to 25, but I think it should get 30, and this should be 20. Five less, let's make it 25. So for example, this is the percentage of influence. I give the highest priority to land cover, slope, and NDVI layers are getting equal priority, 25% wet, and elevation will get 15%. There is no right or wrong answer here. It all depends on how you want to define. Now, I'm happy with the percentage of influence. For this is the column wise, you define which layer is most important and which one is comparatively less important. If you are happy with this, then you click here on the down arrow, and now for each land cover layer, how many categories it has? It has 6 classes or 6 categories. All are showing here. You remember 10 was, if you go to the attribute table from here, you can tell me 10 means vegetation, 30 means bare soil, 60 means open space. I remember them. And you have to define a scale. Like you have to now, within all this category, you have to define which class. Let's say it has 6 classes because we did reclassification. Which class is more important compared to the other one? And for that you can, it's called scale value. You can define a scale. There are lots of options for you. The 1 to 9 is very popular scale. 1 is least important, 9 is most important. That is the HP method. But to make it more simplified, I will be using a 1 to 5 by 1 scale. You can also create your own scale from here. It means for each class you have to give a certain scale value. If you click here now, it will show you 1 to 5 a priority compared to all other classes. You can also restrict the class. Let's do, again, there is no right or wrong answer here. It is all based on how you want to justify your hazard mapping and how you want to represent the local context. So the first one is 10 means vegetation. You can also check the map here. Vegetation is these areas. These are hilly forest. I want to give it, and there are also lots of houses are located also on the hills. I want to give it 3 out of 5. So it's in the middle of the priority. 30 is bare soil. I give it 2. 40 is cropland. Cropland I give 1. Like for landslides, you don't expect too many landslides on croplands. 50 is built up area. The highest number of landslides will occur here. I give it the highest priority. 60 is open space. Again, I give it 1. 80 is water body. There should be no landslides on water bodies, so I will restrict this class. So this is my justification for land cover classes. I'm happy, and close it and go to the next layer, that is reclass, that is slope. This is reclass slope. You can change the color. Slope color should be from lower is green and higher is red, so it should be green to red. And again, you can, based on your experience, the higher the slope, the more risky it is for landslides. So 1 means, if you remember for slope, 1 was 0 to 10 degree, 2 was 11 to 20, and value 5 means between 41 to 90. So I want to give the highest priority for class 5. This is the highest slope, 5. 4, it can be 1, 2 remains 2. 2 means between 11 to 20 degree. It is not highly risky to landslides. I keep it 2. 3 means slope between 21 to 30 degree. This is moderate risky for landslides. I keep it 3. And 4 is between 31 to 40 degree. This is again can be risky for landslides. I will give it 5. This is my justification for scale values for different slope categories. I now go to NDVI. NDVI is a bit tricky. You should know what NDVI represents, what type of land use. This is my NDVI layer, and I know value 1 for NDVI, it represents between minus 0.04 to 0.1, and these are water bodies or low-lying lands and not really very important for landslides. I will keep it still. I will keep it 1. 2 is most important because 2 is NDVI ranges between 0.11 to 0.2. This is mostly built up areas. That's why I give it 5. 3 value represents NDVI between 0.21 to 0.25. These areas are in between hilly forest and agricultural land. You can expect some landslides. I give it 3. And 4 and 5 is higher NDVI. You can expect higher landslides in these areas, but not as much as you expect in category 2 that represents built up. So I will give it again 3 or 2. So this is my justification for NDVI. Done with it. Now last one is elevation. This is the elevation. If you remember, 1 represents elevation between -5 to 10. You really don't expect too much landslides here. I keep it 1. And this is straightforward. The higher the elevation, the more risky that area for landslides. I will keep it straight. Higher elevation to higher priorities for scale value. So I have done all the influence weighting. So these are called assigning weights for all the different layers. I have done it. I'm happy. I think this is representing my study area. You can save the weights as a table, save it somewhere, name it anything, hazard mapping, KRC. Later you can use it straightforward. You don't need to, if you want to change the scale values or influence percentage. So I have saved it, and now it will be, now click OK, and please wait for a while. It is what it is doing. It is now, you can see here the weighted overlay tool is running now based on all your criteria. So for each layer you have first assigned an importance, which layer itself is more important, and then second level, within the same layer you have classes, between 5 to 6 classes, and you then assigned weight for which class is more important than the other one. So we call it a column wise, and then row wise you have assigned weights. So this is the final map. I call it landslide hazard map index. I changed 0 to 5. It has, so the computer has done its calculation, overlay calculations, and 0 means lower and 5 means higher, so the color should be green to red. Okay. So within this color scheme for the hazard map index, the red colors are most vulnerable to landslide hazard within this area, and green is least vulnerable. This is a highly densely populated refugee camp, the Rohingya refugee camps, and almost 60–70% areas are highly landslide vulnerable. So from a quick visual inspection, it looks like this is a real good map. But I don't want so many classes. You can change the classes to whatever number you want. You can go to classified. I want 3 classes. Again, it should be green to red. So the lowest class, I want to name it low hazard, medium hazard, and high hazard areas. You can use hillshade effect, apply, and OK. It is taking time to load. Save the project somewhere. So now we have 3 classes for my final hazard map. Low is the green areas, medium landslide risky areas are the yellow ones, and the red ones are highly landslide hazardous areas. And this is how, by using the weighted overlay tool in ArcGIS with 4 raster layers, I have done the reclassification for some of them. And then based on my own judgment and my own experience, I have assigned weight first column wise, like which layer to give the most priority, then row wise within the same layer, which class should get higher priority. And then it's a very complex analysis, but the software, it did it very quickly for you, and you can very quickly, having a few raster layers, you can quickly produce a nice and authentic hazard map. So that's today's tutorial all about. Thank you, and I wish you all the best.